Okay, picture this. You've just finished reading this incredibly dense, jargon-filled report at work. You get to the very last page, and you realize you retained absolutely nothing. Zero, right? Well, you are definitely not alone. Welcome to today's Explainer. We're unpacking a really fascinating, super practical guide by Roya on mastering learning with the Feynman Technique. Whether you're trying to learn a brand new language, wrap your head around complex physics, or just, survive that Monday morning strategy brief without totally zoning out, this method is literally a game changer for your brain. Okay, let's dive into this. So, if you had to teach a topic you think you know really well to a child, like right now, could you do it? Really think about it for a second. Maybe it's a software program you literally use every single day, or a historical event you just heard about on your commute. This question gets right to the heart of what we're exploring today. You see, we often highlight a bunch of sentences in a book, or we nod along in a reading, and we kind of trick our brains into feeling competent. It's an illusion. It turns out there's a massive and often totally invisible difference between just memorizing facts and actually possessing true foundational understanding. Memorization is fragile. It breaks under pressure, it fades over time, and honestly, it shatters the second someone asks you a simple follow-up question. Understanding, on the other hand, is robust. If you can't explain it simply, well, it turns out you probably don't really get it.
Which brings us to Section 1, the illusion of knowledge and the Feynman philosophy.
Now, what's really interesting about this slide is how we define the core mechanism we're going to be using. The Feynman technique is named after the legendary physicist Richard Feynman. And what really struck me about Feynman is that he wasn't just this brilliant Nobel laureate working on quantum electrodynamics. He had this uncanny, almost magical ability to break down mind-bendingly complex ideas into clear everyday language. People actually called him the Great Explainer because of his incredibly popular freshman lectures at Caltech. So this technique is a mental model revolving entirely around the principle of teaching. It operates on this brilliant premise. Stripping away all that specialized jargon and relying strictly on layman's terms is the ultimate stress test of your own knowledge. It forces you to stop hiding behind big academic words.
And when you adopt this mental model, the benefits are immediate and honestly, quite powerful. It actively yanks you out of that trap of rote memorization, which, let's be real, fades by next week anyway, and pushes you directly into active learning. By stepping into the shoes of the teacher, you instantly deepen your understanding. But perhaps even more importantly, you reveal your own knowledge gaps. You know that visceral feeling, that awful moment when you start confidently explaining something and suddenly you stutter or you go, and realize you don't actually know what comes next? Yeah, that is the gap. Exposing those gaps and actively engaging with them wires the information so much deeper into your brain. It strengthens your memory, and over time, it gives your communication skills a massive boost of confidence because you know you actually understand the nuts and bolts of what you're talking about.
Moving right along to Section 2, 4 Steps to Mastery.
So the crucial point is how you actually execute these 4 specific steps. Step 1 is super straightforward. Identify the concept. Just pick exactly what it is you want to master and write it at the very top of a blank page. Step 2, though, is where the magic really happens. Teach it to a child. You actually write out everything you know using completely simple language. Imagine your audience is an 8-year-old with absolutely zero background knowledge. No $10 words allowed. Then Step 3, review your explanation and find the gaps. Where did you get stuck? Did you use some vague buzzword just to cover up a fuzzy thought? That frustration is actually your cue to go back to your source material and fill in those exact holes. Finally, Step 4, simplify and refine. Rewrite the whole thing again, maybe add a relatable analogy, like comparing a complex computer network to a city's postal service, and make it as absolutely straightforward as humanly possible.
All right, let's look at Section 3, Fixing Unproductive Meetings.
Let's move to and see how this builds into an entirely different arena. Think about the typical corporate meeting and contrast it with the Feynman approach. Usually, we rely heavily on complex jargon, right? We've all been in that boardroom. Everyone nodding along super sagely while someone talks about circling back to synergize our backward overflow paradigms. It sounds incredibly important, but it completely masks the fact that literally nobody in the room actually knows what the plan is. The Feynman approach flips this entirely by relying on simple summaries and the teach-back method. Relying strictly on layman's terms strips away all that corporate fluff. It actively prevents team misunderstandings because it forces absolute clarity. When you can't hide behind jargon, you actually have to make sense.
To make this super actionable, the guide gives us Thor-specific meeting tactics to ensure decisions are crystal clear. Think of these as secret weapons for your next team huddle. First up, clarify your ideas beforehand. Basically, if you can't explain your key points simply before you walk into the room, you aren't ready to present. Second, have the courage to challenge jargon. When someone drops a massive buzzword, politely stop them and just ask, hey, how would you describe that to someone completely outside our industry? Third, summarize the discussion in plain language before moving to the next agenda item. And fourth, I actually found this one fascinating, use the teach-back method. Instead of just asking, does everyone understand, and watching people silently nod, end the meeting by having team members explain the key takeaways in their own words. If they can do it clearly, the message landed. If they fumble, well, you know you need to revisit the topic right then and there.
Now for Section 4, Real-World Applications.
And this brilliantly illustrates just how insanely versatile the Feynman technique is across entirely different domains. This isn't just a trick for studying textbooks. For example, if you're learning programming, you wouldn't just copy and paste code. You test your knowledge by explaining basic syntax out loud without looking at any documentation. For history, you'd break down complex geopolitical events as if you were telling a bedtime story. For dense science, like quantum mechanics, you'd simplify abstract theories using everyday analogies, kind of like comparing the structure of atoms to planetary orbits around the sun. And get this, even for a physical skill, like playing the guitar or swinging a golf club, explaining the basic mechanics simply ensures your brain actually understands what your hands are supposed to be doing. It literally applies to the whole shebang.
We have covered a lot of ground today, but it really all boils down to this incredibly simple truth. True understanding is simple. It's a pretty powerful realization that complexity is, very often, just a mask for confusion. By forcing yourself to explain, to simplify, and to teach, you unlock a level of mastery that rote memorization can never, ever offer. So I want to leave you with a quick question to provoke your next learning session. What complex concept, dense work project, or brand new skill are you going to tackle using this framework? What will you simplify today? Apply the Feynman technique and just watch how quickly your comprehension skyrockets. Thanks so much for joining me on this explainer, and keep learning.